All right, welcome everyone to the engineering lecture series at the University of Wisconsin-Stout. Happy to be joined today by Dr. Carlotta Berry. She is coming to us from the Rose-Hulman Institute of Technology in Terre Haute, Indiana, and where she works in electrical and computer engineering. I always screw up the order on those things. And she helped create a multidisciplinary minor in robotics. And she has done work in education as well as in her research across robotics as well as diversifying STEM. And so with that, I will go ahead and turn it over to Dr. Berry. Thank you so much for joining us today.
Thank you so much for having me. I really appreciate the invitation from Devin as well as the University of Wisconsin at Stout. So I'm now going to share my slides and project the slides. Okay, how do we look?
Looks great to me, thanks.
Okay, so thank you, Devin, for that wonderful introduction. Today I'm going to talk about robotics as a game changer. I like hokey titles, so this is one that's kind of a play on words. And what I mean by robotics as a game changer, one, because there are a lot of robotics competitions where people use robotics for games, but also because the way we think about robotics has to change. So we need to change our game a little. And I'm going to talk about that as well. When Devin, or Professor Berg, I should say, mentioned to me that he wanted me to talk about robotics and human-robot interaction, all week I kept struggling with what did I want to discuss? What did I want to discuss? And finally, I was on social media goofing off, as I tend to do when I can't think and I want to procrastinate. And Robot Dog showed up in New York City on Tuesday, I believe it was. And voila, I had my topic. So I'm going to talk about robotics as a game changer. And I know this is a senior seminar, and I'm trying to write this from the perspective of what's something I would have wanted to hear about as a senior undergraduate in electrical engineering at Georgia Tech. I had all the technical courses. We talked a lot about technically, you know, I do controls, I do robotics, I do human-robot interaction. But what does that mean to the world when I create one of these robotic systems? So looking at that, I'm not just an engineer, but I'm also a Black woman. So as I move in this world and I design robotics or I evaluate robotic systems, I have to think about them in terms of this intersectionality of me as a professor, a woman, a Black person, an engineer. So that's what I'm going to talk about today. How do you define yourself in the context of what you have selected as your career? Ernest Boyer states that the work of the professoriate may be separated into 4 separately yet also overlapping functions: scholarship of discovery, scholarship of integration, scholarship of application, and scholarship of teaching. So this is who you are as a professor, and this is what you bring into the classroom with you or into your research lab or your interactions with your students. So Boyer proposed that there must be a more inclusive view of scholarship where those 4 dynamically interact to make an interdependent whole. So knowledge is acquired through research, synthesis, practice, teaching, and obviously also experience. So how you move in society. So this is the scholarship of discovery, which is investigative research. And it's also the scholarship of integration, which is a synthesis that makes connections across disciplines. Scholarship of application, how do you apply this knowledge you've acquired to consequential problems in service? And scholarship of teaching. So how do you use all of these things you've learned in order to educate and entice future scholars to transmit, transform, and extend knowledge? And what I like to call this, and I made this word up, is nowhere feminism. I'm not a traditional professor because I not only look at the things from those scholars blocks that I just showed you, but I also engage on social media in order to do these things. And I believe that's where Professor Berg found me. So I like to say that I bring robotics and STEM to people, and I bring people to robotics and STEM to educate and diversify the profession. So we look at these things as an interdependent whole that interact and inform each other, such as the robotics, science, technology, engineering, math, as well as people. Because everyone from 9 to 99 can get excited about a robot and about robotics. But let's look at what that means. As the graduating engineers in the room, I'm talking specifically to the students, think about what your STEM means. So here we have a vision of how I see myself doing things as a non-traditional professor. I have teaching in robotics. I do service in robotics. I use robotics for research. I use educating on these social media platforms for robotics so that I can engage with non-traditional students, and I can engage with people and talk to them about how I can help you to make connections between various disciplines by using robotics, as well as looking at how robotics affects society and informs the way that we move in the world. So the first thing we talk about is the Asimovs Laws, which were created by Isaac Asimov in his science fiction book, I, Robot, many, many years ago. And the first law is a robot may not injure a human being or through inaction allow a human being to come to harm. The second law, a robot must obey orders given it by a human being, except where such orders would conflict with the first law. The third law, a robot must protect its own existence as long as such protection does not conflict with the first or second law. And then some years later, someone else added a 0th law that a robot may not harm humanity or by inaction allow humanity to come to harm. So it's a little bit more broad and general than just a human being. And the IEEE Code of Ethics, something we teach our freshman engineering students at Rose-Hulman. We do an assignment on the Code of Ethics, but it doesn't just have to be IEEE. I know some of you are mechanical engineers. ASME also has one. ACM has one. Most professional organizations have one. But here are a few excerpts. To uphold the highest standards of integrity, responsible behavior, and ethical conduct in professional activities. To treat all persons fairly and with respect, to not engage in harassment or discrimination, and to avoid injuring others, and to strive to ensure this code is upheld by colleagues and co-workers. So I want to talk today about how does this relate to robotics? So there are various levels of robot control, from teleoperation, which is remote control, which means the robot has no kind of artificial intelligence. It is completely controlled by a human being, to fully autonomous, meaning it does use some type of artificial intelligence or machine learning in order to engage in the world. But there are several levels in between, which we call semi-autonomous, from guided, which means there's a human giving guidance, but the robot has some level of autonomy that it can make some decisions. Shared and traded means the robot recognizes when it needs perception help and trades with the human being. Supervisory means the robot is supervised by a human that can step in at any moment and take over the task if it feels that the robot is not making adequate progress. And teaming or collaborative, where the robot and the human being work as partners. And I think we would probably consider the robot dog that I'm going to show you today more of the teaming collaborative type, although it's currently completely remote controlled. One of the concerns that people would have is that eventually part of that robot team would have some levels of autonomy that could be subject to bias, right? An example of a teaming robot that is pretty popular right now is the Baxter robot, which is now used in manufacturing, where it's next to a human being and they work together, such as maybe putting together parts of a car or something collaboratively. So I teach mobile robotics because I'm a controls engineer, and this is a good way of representing all of the levels of control, not just from teleoperation to fully autonomy, but looking at global and local control and how that plays a part in the spectrum of things that a mobile robot can do. So a mobile robot moves in a world that's not tethered to anything, unlike an industrial manipulator. So these levels of control have to be able to engage with the real world. And the control architecture is designed by using sensing, planning, and acting. So you normally start in this bottom left corner where the robot is in the real world. It senses data, uses that data to extract information, and that's its perception. For example, an IR sensor or a sonar sensor detects something, and the perception or information extraction could be that's a human, that's a wall, that's a dog, that's a ball, etc. So when we talk about artificial intelligence, some of the concerns with bias are, what kind of information does the robot have accessible in order to make decisions? Because if that information is limited, then the sensing may be limited, which means the decisions the robot makes may be biased. So some of the things a mobile robot could do with that information is to localize if it has a knowledge database, and it's somewhere in the world, but it's not sure where, or it's been kidnapped and placed somewhere unknown in the world. It can build a map, or if it can determine its position with respect to a map, it can use some level of understanding in order to do path planning or execute some mission. Then the final level is acting, which is motion control, where it now acts upon the world. Obviously, this model can be expanded if the robot has more than just navigation tasks, such as you could add a gripper onto the robot to pick things up, or you could have some kind of camera where it's doing some level of image recognition, like maybe looking for people or trying to scope out a certain environment. But this is the most basic level of mobile robot control in the context of navigation. So artificial intelligence is now where you're giving the robot some level of autonomy so that it can do things like create its own internal model of the world, such as in a database. It can now do some kind of planning and reasoning, some level of problem solving or knowledge representation. This figure in the middle is called a sensory egosphere, and it's an excerpt from my PhD dissertation, which I finished many, many moons ago. And it's a way of representing the robot's internal model of the world. So what you see around the side here in this magenta and this aqua color are the sonar and IR data. So the robot can detect where it sees obstacles. And if you notice where the lines are shorter, it's probably detecting either like this red ball or this orange cone, etc. Then also on the nodes of this egosphere would be the locations of items, such as in this case, it's just balls and cones, but you could also use this to represent people or things that you want the robot to go explore, etc. So it's a compact way of representing the robot's artificial intelligence that you can now use to give the robots commands, such as go to the red ball, do you have any green balls in your sight, are there any obstacles near you, etc. So it's a way of representing the robot's intelligence so that it can make decisions about how to move. We like to say that robotics are ideally designed for tasks that are dull, dirty, and dangerous. So if you want them to move without human intervention in one of those type of tasks, it has to have some level of artificial intelligence. So what I did for my PhD work is I put this in a human-robot interface, or a GUI, is a more simple way of putting that. And then remotely, users had to use that interface to tell me things about the robot. For example, if they can't physically see the robot, but they have this interface with a compass, sonar data, IR data, a camera, the sensory egosphere, as well as a map of the building, could a user tell me where the robot is, what obstacles are around the robot, is the robot stuck, is the robot in danger, etc. So this is an example of working the robot's artificial intelligence with a human being to determine how it needs to move in the world. Because if we're using robotics to keep humans safe, then they obviously can't be in close proximity to the robot. And this is the work that I continue. Some things I haven't told you about Rose-Hulman is Rose-Hulman does not have PhD students. The highest degree that we defer is a master's. And many of our master students are course-based. I've had only a few who are not. So a lot of our research is done with undergraduates. So these are some of the things my undergraduate students work on after taking my robotics courses or completing their robotics minor before they graduate, is looking at ways to enhance this interface or create behavior-based control on the robot or things like that. So I want to show you some videos. I always start with a funny one. I show this one in class because I use robotics in my freshman class as well as my senior level classes. And because of TV shows like BattleBots, students always want to do the design challenges and competitions to make the robots fight. And I tell them, we don't think of robots as fighters. We don't think of robots for violence. We think of robots as our babies. These are our robot babies, and we name them. The first thing we always do on the first day of class is we give our robots a name, because I want you to think of them as a precious child that you are giving intelligence through your AI algorithms so that it can accomplish some task. Another reason why I really push back on BattleBots is we don't have a tree full of money at my school. So if we're doing BattleBot competitions where robots are fighting and getting damaged, We can't replace those. And I have to reuse these robots every quarter. So here's my funny intro video that I show to my students of things we do not do with our robots.
Tonight on RoboBest, we got 5-time world champion and Victor. And in this corner, mini fridge.
Todd, what is it?
It's a Bud Light.
Lock on.
With a great taste that won't fill you up and never let you down. Make it a Bud Light.
Oh, no mercy!
And now it's time for my disclaimer. I do not endorse drinking Budweiser or Bud Light. I just wanted to show the BattleBot video. So a big part of being a robotics researcher, which I never thought about as an undergraduate, was what does it mean for my work to now get purchased by someone or used by someone and how they use it. I want to show a video, but I want to start with my trigger warning. And for some reason, the trigger warning keeps disappearing. I am going to show an excerpt of a video from Black Mirror, which is a show that I had actually never heard of, but it had become very popular. Every episode is a different sci-fi topic. It's kind of like the Twilight Zone for the old heads in the room. And I was encouraged to watch Black Mirror. And eventually I watched the first episode. And it was so horrifying. I won't give any details, no spoiler alerts here, but it was so horrifying that I never watched again. And then several years later, somebody said, oh, there's this really cool robotics episode. You should see it. So I've only seen 2 episodes of Black Mirror, and I'm about to show you an excerpt from the second one that I saw, which is called Metalhead. And it has a robot dog in it, which is what I'm talking about today. So I want to show it to you, but I want to warn those who are sensitive that it has some language and some violence. And if that makes you uncomfortable, I am going to recommend that for the next 3 minutes, you mute your microphone and maybe turn away from the screen. And I'm hoping I've given you enough time to do that. So here's one of the challenges with scenes like that. A lot of us became engineers because we wanted to design systems and processes to improve the world by using math and science. But then our technology takes off and we have to become concerned about how it's being used. So it addresses those ethics questions like I talked about in one of the initial slides with the IEEE ethics. On the one hand, you're glad that robots are showing up in movies and people can get some kind of relation to understand what you do. But then all of a sudden, when you're describing to people that you design robots, they're like, oh God, they're going to take over the world. They're going to take my job. They're going to kill me. And you're like, no, I don't design my things to do that. I design them to improve the world. So like I said, I want to share with you a modified version of the video that inspired my talk today from a couple of days ago. I have gone through this one to try to edit out some of the language because I tell my students I don't really like sharing things with curse words in them in class. But I want to apologize in advance if one of them slipped through, but I tried to edit this one to take some of that language out.
Yo, whoa, that's more better than a dog. Oh. Oh, that's R2D2. That's R2D2, y'all. Where is it? Right there, sitting down. Never seen nothing like that in my life. R2D2. I never seen nothing like this before in my life. Do you see this?
So this robot was deployed a couple of days ago because a gunman had entered an apartment with a woman and a baby, and he had basically been hiding from police there. So the dog was just there, but it ended up not being deployed to do anything. But in the past, New York had used robots to go into hostage situations to deliver food, and I think to do surveillance. This robot is completely teleoperated, and as you can see, the person who took this footage was in awe of the robot. But I want to now show you some reactions to that robot being deployed on the streets of New York that were not quite as positive.
Yo, whoa, that's more better than.
New NYPD technology has some people doing a double take and asking questions. As you see, it's a robot that's shaped like a dog. But CBS 2's Tony Aiello tells us more about the controversy about how it's being used.
Monday afternoon, 344 East 28th Street. Cops responded to a man barricaded after a domestic dispute. Sadly, an all too common situation, drawing attention because of this. One of the first times the public has seen the new NYPD DigiDog, bristling with cameras and microphones, able to approach danger and feedback live pictures and sound.
It allows them to really put a plan together to get eyes in there without putting a human body in there. It really gives you that real-time intel that is so critical to any scene like that.
MSA security consultant Justin Kelly used to command the Connecticut State SWAT team. He believes technology such as DigiDog can save lives and money.
There's going to be instances where they're going to be able to determine that, you know, the person's not in the residence. So a 7-hour standoff might be now 90 minutes. Like, there's savings there.
Defund the police critics sounded off on social media, portraying DigiDog as a frightening instance of over-militarized police and, with a $75,000 price tag, wasteful.
They got military gear, and now they got robot dogs in the streets, further oppressing us. We're robots now.
Digidog is made by Boston Dynamics, which continues to develop accessories, including arm attachments. NYPD policy outlines limited use of the robot for situational awareness at dangerous scenes. The mayor says he'll speak with cops about it.
If in any way it's unsettling to people, we should rethink the equation.
Police robots have been around since the 1970s. Never quite like this. Tony Aiello, CBS 2 News.
So I wanted to share a few more reactions because I think as future practicing engineers, we have to be able to articulate our technology to society in a way such that they understand its uses and then it's there as a benefit to make them safer, but not to intimidate or scare people. So as I mentioned, some of these robots have been used for situational awareness, which is basically going in to understand what's happening in the environment, such as with remote robotics, like I talked about doing with my PhD work, where you're trying to remotely assess what's going on, to deliver food in a hostage situation, to scout a location where a gunman was. But some of the backlash, as you've seen, has to do with police overreach, police power, and misplaced priorities. And here's an example from Maya Wiley, who's running for the mayor of New York, who said, rather than, this is a typo, these robots are actually $70,000, not $70 million, invested into saving residents from dangerous mold and lead paint, New York City creates another danger for Black and Latino residents, not when I'm mayor. NYPD deploys creepy new robot dog in public housing. Here's a few more. Robot dogs are here. Should we be worried? From the ACLU. Police dogs also bring awareness to things such as police violence, racism, brutality, and unnecessary killing, which is really big right now in the news for several reasons, including some trials as well as some high-profile shootings. And there are fears that people will start to take advantage and weaponize these robots, and that they will evolve from being remotely controlled to autonomous decision-making. I showed you the levels of control earlier. And that there will be bias and inaccuracy in AI for this decision-making. So in order to make the public comfortable with deploying robotics into these types of situations, there has to be full transparency, meaningful limitations, and also some cities have started to create legislation called community control over police surveillance. For example, New York now has to report out on all of their equipment and what it does. And they have stated that the DigiDogs are actually for surveillance, and that's it. So that's something that, as a matter of time, the public may or may not be comfortable with, because there could be something we call scope creep, where after a while they're used for things other than just surveillance. So you just saw an excerpt from Jamal Bowman in that television the news forecast, but I wanted to also show this to you as well, the news video.
Peace and love, everyone. So all summer, we in these streets protesting for Black lives. We screaming Black Lives Matter. We're marching in solidarity with people from across the city and across the country. We standing up to police brutality directly. And what do we get in return? We got police attacking people, brutalizing people, assaulting people for just walking down the street. We got another killing of Dante Wright. We got the murder of George Floyd, and we got Breonna Taylor and so many others that we can't comprehend. We scream defund the police so we can reallocate those resources towards something that focuses on true public health and public safety. Protesting all summer for Black lives, we were under assault. People living in poverty, struggling to put food on the table, keep a roof over their head, take care of their kids, afford childcare. All this going on. And now we got damn robot police dogs walking down the street. What the hell do we need robot police dogs? This is some RoboCop shit. This is crazy. Robot police dogs walking down the street. So we're saying we need police reform, we need racial justice, we need economic justice. We protesting for Black lives. People pushing back against defund the police. Oh, we need police and this and that. We need robot police dogs? That's what we need? So now, not only do I feel physically occupied in my community by too many police, now y'all bring in robot police to occupy my community? So you can't give me a living wage. You can't raise the minimum wage. You can't give me affordable housing. I'm working hard. I can't get paid leave. I can't get affordable childcare. Instead, we got money, taxpayer money, going towards robot police dogs. Taxpayers fund the police. Taxpayers need to stand up and say enough is enough, because that's crazy right there. That's what you do when you got too much money. They got military gear, and now they got robot dogs in the streets, further oppressing us. We're robots now. It's crazy. We need to end that.
So,
peace and love, everyone.
I don't want to make any political statements about how you feel about defunding the police. It's really about the robot dogs. But I just think we all have to be prepared to be able to speak to general audiences, which means people who may not understand STEM, about the benefits of our work and why it's needed. I'm going to show you a couple more reactions. And this is to justify my premise that humans must be an integral part of the research, development, and deployment process for robotics, as well as any engineering discipline, so that these types of reactions don't happen, right? By educating the community about what they can and cannot do and why they're needed. I mean, some of these are still going to happen. Here's another one from Alexandra Ocasio-Cortez. Shout out to everyone who fought against community advocates who demanded these resources go to investments like school counseling instead. Now robot surveillance ground drones are being deployed for testing on low-income communities of color with under-resourced schools. And of course, someone else had to come out with a PSA. So now we have robot dogs. What do you do if one's near you? Well, we already know that Boston Dynamics says to stay 2 meters away, because at the joint connections, they can crush your fingers and arms. But if you need to disable one, then you need to, if someone's being brutalized by this police spot dog, then you grab that handle underneath in order to release the battery, and you instantly disable the robot. But be careful, because it can crush your fingers. And of course, somebody responded on the thread, what happened to just a good old hammer and bat? Right. So these are other things we have to consider in your design process. So here are a few more quotes from an article that came out in December. And it was an article that was written by several of my Black in robotics colleagues, talking about how can we make sure that the robotics research that we are doing does not end up in the wrong hands and suffer from this type of bias. And I put a couple of quotes here from people who are for and against some of their arguments. So many of today's algorithms are biased against people of color and other who are unlike the white male affluent and able-bodied designers of most computer and robot systems. So that's going to be my justification for more diversity in the room. And Black in Computing released a statement that said, the technologies we help create to benefit society are also disrupting Black communities through the proliferation of racial profiling. And a manifesto came out at the same time called No Justice, No Robots, where signers committed to refuse to work with law enforcement agencies. So in other words, if you're a professor or researcher, you would not apply for grants if you knew they were going to use the products of your intellectual property to go to law enforcement agencies. So one of my other colleagues, Cindy Bethel, who's at Mississippi State University, released a statement saying she was a little dismayed by the No Justice, No Robots manifesto, and she feels that it is a little naive and uninformed to make such a blanket statement, because she currently does work with local and state police on projects that are known to make police work safer for both officers and civilians, such as sending in robots in order to do situational awareness or surveillance in order to keep a human being from risking their lives. So I don't want to tell any audience members where to land on this issue. I'm here to open up a dialogue and a conversation so that as we're working on our technologies, we are thinking about things like how they're going to impact or affect society, and what was your original goal or mission, and is that being met in this process? So other research has shown that robots are not immune to bias and injustice. So here we have Charles Isbell, who's someone who does work in human-computer interaction and AI. And one of the algorithms recently that was shown to have this bias was on Twitter. If you uploaded a pixelated picture of yourself, they had figured out how to create an algorithm in order to fill in that pixelated photo. So here on the left is the original photo. The middle is the pixelated photo that was uploaded to Twitter. And on the right was the AI image processing result. And so this was tried for several images. Barack Obama was turned into a white man. Here, Charles Isbell was turned into a white man. And it was found that this algorithm was biased towards white men. So any pixelated picture, they tried to basically fill in the blanks by making it into a white person. So things we have to explore in our artificial intelligence systems are bias will always be present because it's based on prior information or experience. So as a human being, we only use things we've experienced or things that we know. And so what you have to determine is that bias that's present going to affect a protected characteristic such as race, ethnicity, age, or gender? And once you know and are aware of this, how can you test your system to make sure that this bias is not present? And if that bias is present, you want to ensure that it does not lead to injustice, because it can lead to decisions that negatively impact a protected group, a marginalized group, or lead to injustice. Even if the bias can be intentional or unintentional, it becomes an implicit bias that may hurt these groups. So this image here is Robert Williams. He lives in Michigan. And there was a robbery somewhere, and the store camera was very, very dark, and that image on the left. And what they did is the police department stuck it in their AI image recognition system and compared it to driver's licenses. And then after that comparison, it spit out Robert Williams. And he was arrested on his front lawn in front of his wife and children based upon this faulty AI algorithm and this grainy dark photo here. And it was eventually, of course, discovered that he was not the culprit. And there have now been 2 cases in the last 2 years where this faulty AI system was used against driver's license or against mugshots, and the wrong man was arrested. So here are examples of how this bias in AI can lead to injustice. So how does this happen? It happens because bias in AI and robotics is based upon some type of machine learning that uses model assumptions, and those can only be based upon the information that's accessible. For example, the one that was used for the AI for the pixelated photos, you got to think databases are probably more likely to have more white males than maybe any other population. So if you're using that model to feed into your algorithm, then it may try to fix all pixelated photos as a white male. So you have to ensure that there are no assumptions encoded in your system, and that there's enough of a diversity of data to train your model so that does not happen, and make sure that the information that is present in your systems represents a true model. So here you're going to have your assumptions injected into the system, the training data, the real model data, and some output. And of course, there needs to be someone in the room who assesses it to go, oh, this is not right, or there's something about this data that's biased. A couple of other examples of this. Some years ago, there was a video that went viral on YouTube of a soap dispenser somewhere that had been designed using a sensor that could not detect dark skin. So people could only get soap dispensed if they had white or peach colored hands, or if they put a white paper towel under the dispenser, because it did not recognize dark skin, which means no one in the room had ever tested this on anything other than what the system considered the normal user participant for this would be. Another example was one that was designed many years ago, where they used to make crash test dummies only in the size of an average male. And then they discovered years later that when there were accidents with children, women, pregnant women, etc., they should have had crash test dummies in all of those various times and sizes, and all those various sizes, to address what happens in a crash if you're not the size of an average white male. So once again, that's considered an example of bias in the design process. So how do we address this bias? So the way that we address it is better engineering, obviously. Better engineering in the design method and how it's evaluated. What do the teams look like that work on the system? How is it implemented? What did the data look like that informed the process? And also in policy in, if you're delivering your product to a end user, how will it be used? Have things in writing such that, for example, that DigiDog, they can't attach a gun to it, right? It can only be used as a remote control mode. It can't have any AI on it. So this image here is Joy Bulawemi from her documentary Coded Bias, which actually just came out recently, I think worldwide. And she's a graduate student that talked about that she wanted to use image recognition for a school project and could not figure out why it wasn't working, and then discovered that when she put a white mask on, it did, because the image recognition system did not recognize dark skin. So it's a wonderful documentary that I highly recommend that you watch it if you have the time. And there are actually excerpts of it on YouTube, I believe. So that's what human-robot interaction is all about. How do you get the human in the loop and look at not just these technologies, but how it informs the way humans engage with it, interact with it, and you eliminate bias. So it's a field of study to understand, design, and evaluate robotic systems for use by or with humans, to develop principles for natural and effective communication between human and robots. And obviously that extends to interaction as well. The cool thing about human robot interaction is that it hits on a lot of fields: robotics, human-computer interaction, computer science, psychology, electrical engineering, cognitive science, mechanical engineering, sociology, you name it. And in fact, at Rose-Hulman, this is how we try to implement our robotics minor, by having the students work together in a multidisciplinary format. There's no such thing as silos anymore with only mechanical engineers, electrical engineers, and computer scientists. All the students work together in their class projects as well as a senior design project if they take multidisciplinary senior design, so that they can learn to speak each other's languages and do some basic tasks that other people do. For example, computer scientists now know something about hardware. Electrical engineers also do software development, and mechanical engineers would do some controls and sensing, as well as computer sciences as well. Because when you graduate, you typically don't just go and work with all mechanical or electrical engineers. You need to be able to speak their language as well. This is part of that eliminating bias by having robots and humans work together in a system to interact and engage, right? So you're going to have roles, mental models, behavior and response of the humans, expectations interacting, different modes of communication, and the robot has capabilities for this interaction. And then the intersection of those two is the research area, human-robot interaction. So the goal is to design systems that create teams of humans and robots that are efficient and effective and take advantage of the skills of each team member. So ways to get rid of the bias in the effect is, if you look here, I can't remember, this is probably from this KCDC, I think that's the name of it. I've had this video for so long. I mean, this comic, I don't remember where I got it from, but you need to look at the way things are communicated, the robot's response and the user's response. So this is from Terminator, right? Obviously the robot has a gun and looks really scary. So if it asks, is that Sarah Connor? Nope, absolutely not. But if it just says boinky, boinky, cutie, cutie, are you Sarah Connor? Maybe, likely, it might say yes, right? So how things are represented and how you respond. So we need diverse, multidisciplinary teams in the room to change the game. That's the key. We all have to be aware of bias, and we need to have teams that reflect the world that we live in, so that they give these different perspectives of, hey, this thing doesn't recognize my face, or hey, it doesn't recognize me because I'm too short for how it was designed, or my skin color, or whatever. And this is how robotics and engineering becomes a game changer. By changing how we approach these problems, changing how we think about these problems, how we evaluate them, how we design them. So Black in Robotics is one of the two organizations that I am a founder for. The other one is Black in Engineering. They have very similar missions, but here is the mission for Black in Robotics: to bring together Black researchers, industry professionals, and students in robotics to mutually support one another to help navigate academic, corporate, and entrepreneurial paths to success, to advocate for more diversity, inclusion, and equity within the organizations that we live and work in, to ensure a seat at the table during the development, test, and deployment of robotic systems that affect our communities, and to amplify our collective voices for calls for social justice. So I hope you've seen that I've hit on several of those in this presentation already. And now some of the strategies that Black in Robotics has come up with for addressing bias. Developers must consider ethical implications of robotics usage. Educators must include ethics and societal questions in training, which means in your curriculum, which I believe ABET has some. Teams must be diverse to provide unique perspectives and solutions. And researchers must reference the work of diverse roboticists. Here's an image of Jeremy Delane Brown, and he is a professor at Johns Hopkins University, where we had, as part of normalizing and amplifying Black roboticists, there's not only a reading list that includes a list of Black researchers and professors and academics in robotics, but we had them post these to social media around Christmas time. So here he is showing some of the work that he does with an articulated arm in robotics research. Not an articulated arm, I think it's a rehab arm. I don't know, I don't want to misspeak. And here's another from TechOver. She is not a professor. She, I believe, is still a student who is on Instagram, but normalizes doing robotics work as well. And so she's showing one of her robots. And in addressing these systemic inequities in robotics, we have to look at community, such as networking, mentorship, and a social media presence and awareness. Advocacy, by showcasing and normalizing Black excellence in robotics. Connecting academia and industry to diverse talent. Supporting and defending equity in performance and ethical use for robotics, as well as having accountability. A conduit for all roboticists to participate in solutions, identify best practices, and hold each other accountable for equitable designs. So some of our next steps are to actively promote diversity in developing teams in academia and industry, ensure that bias is considered in the research and application of robotic systems, and make bias training and its effect in robotic applications and methods of mitigating harm a component of the curriculum. So here is Aaron Shepard. He's an intern at NASA, and he's also a graduate student. And he also has a large social media presence on like TikTok, where he's normalizing doing robotics. And here he focuses on biomimetic robots, or robots that have animal-like appendages and behavior. All of their work is amplified on our social media at Black in Robotics Twitter, as well as Instagram and things like that. So in conclusion, robotics is a game changer. It's a game changer because obviously I think it's extremely cool, but I think that we have to change the way we think about how it's deployed and used and how it's designed in order to make sure that there is no bias in the process or bias in its end use at the end. So I'm really here to welcome questions now, but I wanted to give you several ways to reach out to me. Obviously my website and my email, but you can also connect with me on Twitter, Instagram, or TikTok. I'm new to the TikTok game. I'm doing that because it was National Robotics Week, and I'm trying to amplify more of our work. And some of my students told me that, of course, Facebook and Instagram are old news among you youngins now. So I'm trying to get into the TikTok game, but also to connect with the work of Black in Engineering and Black in Robotics. These are their websites, or you can connect with them on Twitter or Instagram as well. And thank you. I am now ready to engage in questions or discussion, so I will stop sharing.